universe looks silent, cold, endless. When humans look into the night sky, they see stars shining peacefully. Galaxies move slowly as if everything is calm and under control. But scientists say this calm view is an illusion. Deep beneath this quiet surface, the universe is restless. Invisible forces are at work. Tiny particles appear and disappear. Energy vibrates everywhere. Reality itself is unstable. This is where the story truly begins. For thousands of years, humans tried to understand the universe. Ancient civilizations believed the stars were gods. Later, scientists believed the universe was a perfect machine. Every movement had a reason. Every event had a clear cause. But in the 20th century, something unexpected happened. Scientists discovered a hidden world, a world so small that it cannot be seen with the human eye. A world that does not follow normal rules. This world is called the quantum world, and it changed everything. At the quantum level, reality behaves in a strange way. Particles do not act like solid objects, they behave like waves. They exist in many states at the same time. A particle can be here and there, moving and still, alive and gone. This strange behavior shocked scientists, because if the smallest building blocks of the universe are unpredictable, then what does that say about reality itself? This question still haunts modern science. The universe is made of atoms. Atoms are made of smaller particles, electrons, protons, and quarks. These particles are not tiny balls. They are probability waves. This means they do not have a fixed position until they are observed. Reality waits to be seen. This discovery forced scientists to rethink everything they knew about space, time, and matter. The universe was no longer a solid structure. It became a shifting, uncertain system, a cosmic mystery. One experiment changed human understanding forever. It is called the double-slit experiment. When particles pass through two small openings, they behave like waves. They create a wave pattern. But when scientists observe them, the same particles behave like solid objects. Observation changes reality. This means the universe reacts when it is watched. But who is watching the universe? And why does reality care? Albert Einstein struggled with these ideas. He believed the universe must be logical and predictable. Quantum mechanics challenged this belief. Einstein once said, "God does not play dice with the universe." But experiments proved otherwise. The universe does play dice. Chance is built into reality. Nothing is fully certain. As scientists looked deeper, the universe became even stranger. Particles were found to be connected across vast distances. Two particles could share information instantly, even if they were separated by light years. This connection is called quantum entanglement. When one particle changes, the other changes immediately. No signal travels between them. No time delay exists. This breaks the laws of space. Einstein called it spooky action at a distance. Yet, it is real. This suggests the universe is not made of separate parts. Everything may be deeply connected at a hidden level. The universe may be one single system. If this is true, then space is not empty. It is filled with energy, filled with information, filled with quantum activity. Even in complete darkness, particles are appearing and disappearing. This invisible ocean is called quantum vacuum. It is not nothing. It is everything waiting to happen. Scientists now believe that the universe itself was born from this quantum vacuum. Before time existed, before space expanded, a tiny quantum fluctuation occurred. That fluctuation grew. It expanded faster than light. It became the universe. The Big Bang was not an explosion in space. It was an expansion of space itself, and quantum mechanics made it possible. The early universe was unstable. Energy was chaotic. Laws of physics were still forming. Tiny quantum changes decided the future of everything. A small difference in the beginning could have destroyed everything. Yet, the universe survived. Stars formed. Galaxies were born. Life became possible, all because of quantum rules. This raises a powerful idea. If quantum mechanics controls the smallest particles and these particles build everything, then quantum rules control the entire universe. From the birth of stars to the beating of a human heart, everything follows quantum laws. But there is a darker side to this discovery. Quantum mechanics suggests that reality is not fixed. It exists as probabilities. This means the future is not written. Everything is possible until it happens. The universe is constantly choosing between outcomes. Every moment, reality collapses into one version, but other possibilities may still exist. Some scientists believe this leads to multiple universes. Every decision creates a new reality, a new universe. If true, then countless universes may exist beside ours. Invisible, silent, unreachable. This idea is terrifying, because it suggests humans do not live in a single universe. They live in one version of many, and quantum mechanics decides which version becomes real. As technology improves, scientists build machines to explore this hidden world. Particle accelerators smash atoms together. Quantum computers use uncertainty as power. These machines do not fight quantum chaos. They use it. Quantum computers can process information in ways normal computers cannot. They exist in many states at once. They calculate many answers at the same time. This technology may unlock secrets of space, time, and reality itself, but with knowledge comes fear. If reality is uncertain, can it be controlled? Can humans change the fabric of the universe? Can they rewrite the rules? Some scientists believe quantum technology could unlock new dimensions. Others warn it could destroy reality as we know it. The universe is no longer just something humans observe. It is something they interact with. Every observation changes it. Every experiment leaves a mark. The universe responds. This leads to the most disturbing question of all. If observation affects reality, then what is consciousness? Is the human mind just a byproduct of quantum processes, or is it something more? Some theories suggest consciousness itself is quantum. That awareness is not separate from the universe. It is part of it. If this is true, then humans are not outsiders looking in. They are woven into the fabric of reality. The universe is not happening around them, it is happening through them. The deeper scientists look, the more the universe feels alive, not conscious like humans, but responsive, dynamic, unpredictable. The universe is not a machine, it is a process. This is only the beginning. Quantum mechanics has opened a door humans can never close. Behind that door lies the true nature of reality. A reality where space bends, time slows down, and certainty disappears. In the next part, the journey will go deeper into the quantum world where particles break rules, distance has no meaning, and reality becomes a puzzle with no clear answer. Because to decode the universe, humans must first accept one truth: reality is far stranger than imagination. And the universe has only just begun to reveal its secrets. The universe has rules. At least that is what humans believed for centuries. Planets move in fixed paths. Stars are born and they die. Time flows forward, never backward. Everything seems ordered. But when scientists looked closer, much closer, they discovered a world where these rules collapse. A world where logic fails. This is the quantum world. At the smallest scale of existence, particles do not behave like objects, they behave like possibilities. An electron does not travel in a straight line, it spreads like a wave. It exists everywhere until it is measured. Only then does it choose a position. This strange behavior shocked physicists, because it means the universe does not decide reality until the last moment. Reality is delayed. In classical physics, knowing everything means predicting everything. If speed and position are known, the future is clear. Quantum physics destroyed this idea. There is a fundamental limit to knowledge. It is called the uncertainty principle. This rule says a particle's position and speed cannot be known at the same time. The more precisely one is known, the less the other can be known. This is not a problem with tools. It is a rule of nature. The universe does not allow complete certainty. This uncertainty is not a mistake. It is built into reality. At the quantum level, the universe prefers freedom over control. Particles are not forced into paths. They explore all possibilities. Only when observed do they settle. One of the strangest discoveries in quantum science is superposition. A particle can exist in multiple states at the same time. It can be moving and still, spinning left and right, alive and decayed. Only observation forces it to choose. Until then, all possibilities exist together. Reality is layered. To understand this, imagine a coin spinning in the air. Before it lands, it is both heads and tails. Quantum particles behave the same way. But unlike the coin, they never land unless someone looks. This strange rule is not just theory. It has been tested countless times, and every time quantum mechanics wins. The universe behaves exactly as predicted: strange, uncertain, and unpredictable. But the quantum world holds an even deeper mystery. Particles can communicate without space. They can connect instantly. This phenomenon is called quantum entanglement. When two particles become entangled, they share a single state. They are no longer separate, they become one system. If one particle changes, the other changes instantly. Distance does not matter. They could be meters apart or galaxies apart. The result is the same. This discovery shocked scientists. According to classical physics, nothing can travel faster than light, but entanglement breaks this limit. Information appears to travel instantly. This should be impossible, yet experiments prove it is real. Albert Einstein rejected this idea. He believed something must be hidden. Some unknown rule must explain it, but no hidden rule was found. Reality truly behaves this way. The universe allows instant connection. This suggests something disturbing. Space may not be fundamental. Distance may be an illusion. At deeper level, everything may already be connected. The universe may not be made of separate objects, it may be a single network. If this is true, then the universe is not built from space. Space may emerge from quantum connections. Reality may be woven, not placed. This idea changes everything. Time also behaves strangely in the quantum world. At small scales, time loses direction. Processes can move forward and backward. Cause and effect blur. Some equations work the same in both directions. This suggests time may not be fundamental either. It may emerge from deeper quantum processes. If space and time are not fundamental, then what is? Some scientists believe information is the true foundation of reality. Particles are not objects. They are packets of information. Reality is a quantum code. This idea leads to a shocking possibility. The universe may function like a computation, a vast quantum system processing information. Stars, planets, and life are results of this process. Reality is not built. It is calculated. This concept is not science fiction. Quantum computers already use these principles. They do not use certainty. They use uncertainty. Instead of bits, they use qubits. A qubit can be 0 and 1 at the same time. This allows massive parallel calculation. Problems that take normal computers thousands of years can be solved in minutes. These machines are fragile. Small changes destroy calculations. They must be isolated from reality. This shows how delicate the quantum world is, but it also shows how powerful it can be. Quantum technology may change humanity forever. It may unlock new materials, new energy sources, new understanding of space and time, but it also comes with risks. Some scientists fear quantum systems could collapse unpredictably. Others worry about loss of control. When reality is uncertain, mistakes become dangerous. The quantum world is not friendly. It is indifferent. It follows rules but not human logic. Understanding it requires letting go of certainty. Despite these dangers, humans continue to explore, because the quantum world holds answers. Answers about the universe's origin. Answers about reality itself. Quantum mechanics also challenges the idea of objective reality. If observation changes outcomes, then reality depends on interaction. There may be no single version of events, only probabilities. This idea troubles many scientists because science depends on objectivity, but quantum experiments show otherwise. Reality is participatory. This leads to different interpretations. Some believe reality collapses when observed. Others believe all outcomes occur in separate universes. This is called the many worlds interpretation. Every quantum decision creates a new universe. If true, then reality constantly splits. Every moment, countless universes are born. In one universe, a particle goes left. In another, it goes right. Both are real, but humans experience only one. This idea is unsettling. It suggests humans are not unique. There are endless versions of everything, living different lives, making different choices, all equally real. Whether this is true remains unknown. Quantum theory works, but its meaning is unclear. The universe gives correct answers but refuses to explain itself. Scientists accept this uncertainty. They use quantum rules without fully understanding them because results matter. Understanding can wait. The quantum world is not something far away. It exists everywhere, inside atoms, inside cells, inside human bodies. Life itself depends on quantum effects. Photosynthesis uses quantum efficiency. Bird navigation may use entanglement. Even smell may involve quantum processes. This means the quantum world is not separate. It is part of daily life. Humans live inside a quantum universe. The deeper science goes, the clearer it becomes. Reality is not solid. It is fluid, not fixed, but responsive. The quantum world is not chaos. It has structure, but not certainty. It allows freedom, and that freedom shapes the universe. In the next part, the journey will move outward, from tiny particles to cosmic beginnings, from quantum uncertainty to the birth of space and time, because the universe itself may be a quantum event, and understanding that event may reveal why anything exists at all. The rules are broken, certainty is gone, and the universe has never been stranger. Before stars existed, before galaxies formed, before time itself began, there was nothing, no space, no light, no direction. At least that is what humans once believed. But modern science suggests something very different. Before the universe was born, there was not nothing. There was quantum energy. The story of the universe does not begin with stars or planets. It begins with a moment beyond imagination. A moment where all known laws of physics collapse. This moment is called the Big Bang. But the Big Bang was not an explosion in space. There was no space to explode into. It was the birth of space itself, and quantum mechanics played a key role. Scientists believe that the early universe was extremely small, smaller than an atom, smaller than anything measurable. In this tiny state, quantum rules dominated everything. Uncertainty ruled, fluctuations were normal, nothing was stable. In quantum physics, empty space is never truly empty. Even in total darkness, energy exists. Particles appear and disappear constantly. This restless background is called quantum vacuum. It is not calm, it is alive with activity. According to modern theories, the universe was born from a quantum fluctuation in this vacuum, a tiny change, a moment of imbalance. That small fluctuation expanded, and it never stopped. This expansion is known as cosmic inflation. In a fraction of a second, space expanded faster than light. Distances that were once microscopic became cosmic. This rapid growth smoothed the universe. It made it large, it made it flat, it made it stable enough for matter to form. Without inflation, the universe would collapse instantly. Quantum fluctuations during inflation were stretched across space. These tiny variations became seeds, seeds of galaxies, seeds of stars, seeds of everything. The largest structures in the universe were born from the smallest quantum changes. This idea is almost impossible to imagine. A tiny quantum vibration deciding the position of galaxies billions of light years away. Yet observations confirm it. Patterns seen in cosmic background radiation match quantum predictions. The universe carries the fingerprints of its quantum birth. After inflation slowed, energy transformed. Particles formed. Forces separated. Physics took shape. Time began to flow forward. Space gained structure. The universe entered its first moments. At first, the universe was too hot for atoms. Only energy existed. Then, as expansion continued, temperatures dropped. Particles slowed. Quarks formed protons and neutrons. Later, electrons joined them. Atoms were born. Light could finally travel freely. The universe became transparent. This ancient light still exists today. It is called cosmic microwave background radiation. It is a faint glow filling the universe. A message from the past, a snapshot of the universe as a baby. This radiation shows small temperature differences. Those differences match quantum fluctuations from the beginning of time. This is powerful evidence. The universe remembers its quantum origin. As time passed, gravity took control. Matter gathered, gas clouds collapsed. The first stars ignited. They burned bright. They created heavier elements. They exploded. Their remains formed new stars and planets. Everything humans see today comes from this process. Every atom in the human body was forged in stars. But the story began far earlier. At the quantum level, quantum mechanics did not disappear after the Big Bang. It continues to shape the universe. Even today, black holes follow quantum rules. Black holes are regions where gravity becomes extreme. Space bends infinitely. Time slows down. Classical physics fails. Inside black holes, quantum effects dominate. According to some theories, black holes are not empty. They are filled with quantum information about everything that ever fell inside. Stephen Hawking discovered that black holes are not completely black. They slowly emit radiation. This radiation is quantum in nature. It suggests black holes can lose mass. They can even evaporate. This creates a paradox. If black holes destroy information, quantum mechanics is broken. But quantum laws say information can never be destroyed. This contradiction remains unresolved. It is one of the deepest mysteries in physics. Solving it may unlock the connection between quantum mechanics and gravity, a theory that explains everything. Scientists search for a quantum theory of gravity. They want to unite the very small with the very large. Quantum mechanics and general relativity. Particles and spacetime. One idea is string theory. It suggests particles are tiny vibrating strings. Different vibrations create different particles. Space may have extra dimensions, hidden, curled up, invisible. Another idea is loop quantum gravity. It suggests space itself is made of tiny loops. Space is not smooth, it is pixelated, made of quantum units. These theories are not proven, but they suggest one thing clearly. Space and time may not be fundamental. They may emerge from quantum processes. If true, then the universe is not built on space. Space is built on quantum reality. This changes the meaning of existence. The beginning of time itself becomes questionable. If time emerges from quantum rules, then asking what happened before the Big Bang may not make sense. Before time, there was no before, only possibility. Some scientists believe universes can be born constantly, each from a quantum event. This is called the multiverse idea. Our universe may be one of many, each with different laws, different constants, different realities. In some universes, stars never form. In others, atoms collapse. Only a few allow life. This may explain why our universe seems perfectly balanced, because only such universes can be observed. This idea is controversial, but it is based on quantum logic, the same logic proven in experiments. Quantum mechanics forces humans to accept discomfort. Not everything has clear answers, not everything is observable, but reality still exists. The universe did not begin as a machine, it began as uncertainty. From that uncertainty came structure, from structure came complexity, from complexity came life. This suggests something profound. Order can arise from chaos. Reality does not need certainty to exist, it only needs rules. Quantum mechanics provides those rules, simple, mathematical, strange, yet powerful enough to create a universe. Humans are children of a quantum event. Their existence depends on probabilities decided billions of years ago. A different fluctuation and nothing would exist. This realization is humbling. The universe is not designed for humans. Humans are shaped by the universe. As science advances, the quantum origin of reality becomes clearer, but understanding remains incomplete. The deeper humans look, the more mystery they find. In the next part, the journey will turn inward, toward a question that challenges science itself. If quantum mechanics shapes reality, what role does observation play? Does the universe need a witness? And is consciousness connected to the fabric of reality? Because the greatest mystery is not how the universe began, it is how reality becomes real. And the answer may lie in the act of observation itself, at least that is what humans believe. Stars shine, galaxies move, time flows forward, but quantum science asks a dangerous question. Does the universe exist if no one is watching? For centuries, scientists believed reality was independent. Mountains existed whether humans saw them or not. Stars burned even if no one looked at the sky. Reality was solid, objective, unchanging. Quantum mechanics challenged this belief. At the smallest level of existence, particles behave differently when they are observed. This is not philosophy, it is proven by experiments. In the famous double-slit experiment, particles behave like waves when unobserved. They spread, they interfere, they act as possibilities. But the moment scientists observe them, the wave disappears. The particle chooses a single path. Reality changes. This phenomenon is called the observer effect, and it is one of the most unsettling discoveries in science. Observation does not just reveal reality, it creates it, at least at the quantum level. This raises a terrifying idea. If particles do not choose a state until observed, then what is reality doing when no one is looking? Is it waiting, or does it not exist at all? Scientists try to explain this effect without involving consciousness. Some say measurement devices cause the change. Others say interaction forces particles to choose, but deeper analysis reveals a problem. Even automated machines cause collapse. Even systems with no human presence still count as observation. So what exactly is observation? Is it awareness, or interaction, or information exchange? Quantum mechanics does not give a clear answer. It only gives results. And the results say this reality depends on interaction. Some interpretations go further. They suggest that consciousness plays a role, not just tools, not just machines, but awareness itself. This idea is controversial. Many scientists reject it. They fear mixing physics with philosophy, but the questions refuse to disappear. Why does the universe care about observation? Why does measurement matter? Why does reality behave differently when watched? One idea suggests the universe is incomplete without observers. Reality exists as probability. Observation turns possibility into fact. This does not mean humans control the universe, but it may mean they participate in it. Some physicists believe consciousness collapses the wave function. Others believe the universe collapses itself. There is no agreement, only mystery. If consciousness is involved, then it must be physical. It must arise from the brain, and the brain itself operates using quantum processes. Some theories suggest consciousness emerges from quantum activity inside neurons. Tiny structures inside brain cells may maintain quantum states. These states may influence awareness. This theory is debated, but it raises an important point. If consciousness is quantum, then awareness is part of the universe's deepest layer, not separate, not special, but connected. This would mean humans are not passive observers. They are active participants. Reality happens through interaction. This idea changes the human role in the cosmos. Humans are no longer spectators. They are part of the process that makes reality real, but there is another interpretation, one that avoids consciousness entirely, the many worlds interpretation. According to this idea, reality never collapses. All possibilities happen. Every quantum decision creates a new universe. Observation does not choose, it separates. In one universe, a particle goes left. In another, it goes right. Both are real. Humans experience only one path. In this view, consciousness does not shape reality, it follows it. Observers become entangled with outcomes. They experience one branch. This interpretation removes mystery, but adds something even more disturbing. Infinite universes, infinite versions of everything, every decision, every event, every moment. Reality constantly splits. If this is true, then existence is unimaginably vast, and humans occupy a tiny thread in a limitless web. Which interpretation is correct? No one knows. All interpretations predict the same results. Quantum mechanics works perfectly, but meaning remains unclear. This is frustrating for science. Usually theories explain reality. Quantum theory predicts it, but refuses to explain why. The universe gives answers, but hides its reasons. As experiments become more advanced, the mystery deepens. Scientists create quantum systems isolated from the environment. They delay observation. They test reality itself. Some experiments suggest observation can be delayed. Particles behave as if future measurements affect past behavior. This challenges causality. The future influences the past. Time itself becomes uncertain. In quantum mechanics, cause and effect are not always clear. Events do not always follow order. Reality becomes nonlinear. This suggests time may not be fundamental. Like space, it may emerge from deeper rules. If time is flexible, then observation is not tied to a moment. Reality may be formed across time, not at a single point. This breaks human intuition, but quantum mechanics does not care about intuition. It follows math. Despite confusion, one thing is clear. Reality is not independent. It is relational. It exists through interaction. This idea aligns with ancient philosophies. Many cultures believed reality is interconnected. Nothing exists alone. Quantum physics echoes this idea through science. The universe may not be a collection of objects. It may be a network of relationships. Particles, forces, observers, all connected. This network creates experience. Without interaction, there is no reality, only possibility. Humans are part of this network. Their observations matter, not because they are special, but because interaction matters. This idea does not give humans power over the universe. It gives them responsibility. Every action interacts with reality. Every measurement leaves a trace. Science itself becomes participatory. By studying the universe, humans change it. This does not mean truth is subjective. Quantum rules are strict. They do not bend for belief, but they allow flexibility. Reality is not fixed. It is responsive. This challenges the classical idea of a cold, mechanical universe. The quantum universe is dynamic, creative, alive with possibility. The observer effect does not say reality is imaginary. It says reality is conditional, dependent on relationships. This may be the deepest lesson of quantum mechanics. Existence is not isolated. Nothing stands alone. As science continues, these ideas move from philosophy to experiment. Quantum technologies rely on observer effects. Quantum communication uses entanglement. Quantum measurement becomes engineering. The strange rules of reality become tools. Humans no longer ask if quantum mechanics is true. They ask how to use it, but understanding still lags behind power. The universe is being shaped before it is understood. This creates urgency. Because without understanding, mistakes are possible. The observer effect reminds humanity of humility. Reality is not fully known. Certainty is an illusion. The universe is not just out there. It is intertwined with those who observe it. In the next and final part, the journey reaches the future, toward quantum technology, toward the search for a theory of everything, toward the ultimate question. Can humans fully decode the universe? Or will reality always remain one step ahead? Because understanding the universe is not just about space and time. It is about knowing what it means to exist, and whether reality itself is watching back nearly 14 billion years old. Yet in many ways, humanity has only just begun to understand it. After centuries of observation, calculation, and discovery, one truth has become clear. The universe is not simple, and it never was. Quantum mechanics has revealed a reality that is uncertain, connected, and deeply mysterious. Particles exist as possibilities. Space may not be fundamental. Time may not flow in one direction. And observation itself may shape what becomes real. Now humanity stands at a turning point. The age of discovery is becoming the age of control. Quantum science is no longer just theory. It is becoming technology. Across the world, laboratories are building machines that operate using the rules of uncertainty. Quantum computers. Unlike classical computers, they do not process information step by step. They explore many outcomes at the same time. They exist in multiple states. They calculate reality in parallel. These machines promise extraordinary power. They could simulate molecules perfectly, design new medicines, solve complex climate models, break modern encryption. Problems once considered impossible may become trivial, but this power comes with risk. Quantum systems are extremely sensitive. A small disturbance can destroy calculations. Noise collapses quantum states. Reality itself interferes. This shows something important. The quantum world is not easily controlled. It resists stability. It prefers uncertainty. As humans push deeper, they face a choice. Use quantum power carefully or lose control of systems they barely understand. Beyond computing, quantum communication is changing how information travels. Using entanglement, messages can be shared securely. Any attempt to observe the message changes it. Security becomes a law of physics. Quantum sensors can detect tiny changes in gravity, time, and space. They may reveal hidden structures of the universe, even dark matter, even distortions in space-time. The universe is no longer just observed. It is being measured with quantum precision. At the same time, scientists search for the final goal, a theory that explains everything, a single framework connecting quantum mechanics and gravity. This dream is called the theory of everything. It would explain why the universe exists, why laws are the way they are, why reality takes this form. So far, the universe has resisted. Quantum mechanics works at small scales. General relativity works at large scales, but together they conflict. At the center of this conflict lie black holes, places where space collapses, where time slows to nothing, where information seems lost. Solving the black hole puzzle may unlock the deepest truth of reality. It may reveal whether information is eternal, whether reality is reversible, whether time itself can end. Some scientists believe the universe is holographic, that all information inside space is stored on its boundary. Reality becomes a projection. 3 dimensions emerge from 2. If true, then the universe is not what it appears to be. Depth is an illusion. Reality is encoded. Others believe space is made of quantum units, tiny blocks of geometry. Time advances in steps, not continuously. In these models, the universe resembles a vast quantum network. Information flows, geometry emerges, reality updates. This leads to a shocking possibility. The universe may behave like a simulation, not created by intelligence, but by physics, a natural computation. This idea is controversial, but it is taken seriously because it follows from quantum logic. If reality is informational, then existence is not material at its core. It is mathematical, structural, abstract. This challenges the meaning of existence. Are humans physical beings or patterns in a cosmic code? Yet meaning does not disappear, it changes. Humans are made of the same quantum rules that shape stars. Their thoughts arise from the same laws that guide galaxies. They are not separate from the universe, they are expressions of it. This realization is profound. It removes the idea of dominance and replaces it with connection. The universe did not create humans by design, but humans are capable of understanding the universe. This may be rare, this may be precious. As quantum science advances, ethical questions emerge. Should everything that can be done be done? Should reality be manipulated without full understanding? Power without wisdom is dangerous. History has shown this. Quantum power may be the greatest humanity has ever held. Some scientists warn of existential risks. Others see hope. Quantum science may help solve energy crises. It may help protect the planet. It may help humanity survive. The future is not fixed. Quantum mechanics itself teaches this. Multiple paths exist. Only choices decide which becomes real. This applies not only to particles, but to civilizations. Humanity stands in superposition, between wisdom and destruction, between curiosity and control. The universe does not guide this choice, it only allows it. Perhaps the final lesson of quantum reality is humility. Certainty is an illusion, control is limited, understanding takes time. The universe is not obligated to be simple. It is not obligated to be comforting, it simply exists. And yet, it allows itself to be explored. One experiment at a time, every discovery reveals deeper mystery. Every answer creates new questions. This is not failure, it is the nature of reality. The universe is not a puzzle to be solved once. It is a story that unfolds endlessly. Quantum mechanics did not end wonder. It multiplied it. The stars above are no longer distant lights. They are consequences of quantum events. The atoms within the human body were shaped by cosmic uncertainty. Existence itself is a delicate balance. From nothing came possibility. From possibility came structure. From structure came life. And from life came awareness. The universe became aware of itself. Perhaps this is the deepest truth. The universe is not just expanding, it is understanding itself through science, through observation, through consciousness. Humans are not separate from this process. They are part of it, temporary, fragile, but meaningful. The journey to decode the universe will never truly end. Because the universe is not static, it evolves, and so does understanding. The final truth may never be reached. But the search itself defines humanity, to look into the unknown, to accept uncertainty, to ask questions without fear. Quantum reality teaches one final lesson. Not everything needs an answer to have meaning. The universe is strange, beautiful, unpredictable, and somewhere between probability and observation, between chaos and order, between question and answer, reality continues. Not fully known, never fully controlled, but endlessly explored. This is not the end of the story. It is only the edge of understanding, and beyond that edge the universe waits. Clapperboard. End of documentary.